Thanks so much for being here today. And first, before we begin, I just wanted to mention that I did include my Twitter handle in the upper right corner if that's something that you wanted to do. I won't be offended if you're looking at your phone and not at me. So the title of my talk, as you can see here in the program, is Bridging the Knowledge Gap of Debugging. To me, that's really just a fancy way to say that this is a talk about what I wish 2018 me knew about debugging. So to start, a little introduction. My name is Mina, and my pronouns are she, her, and hers. I graduated from a coding bootcamp in April of 2018, and I am currently a software engineer at Tandem, which is a consulting agency in Chicago. And fun fact, I'm very nervous right now. All right, so all right, this is the third time I've given this talk. I've never gotten that reaction to this, so cool. So if you were in a career for many years like I was, starting a new job in a new field is really scary. So I was transitioning from a 10-year career in theater, where I was the expert at my job, to a new industry and a team where everyone knew more than I did. Okay, so I knew I was going to be the most inexperienced developer at my entire company, but I was ready to face the challenges of this new career head-on. I was mentally prepared to put a lot of energy into learning and improving and becoming the best developer that I could, but I wasn't really prepared to discover just how much I didn't know. Now, I quickly found where my skills were lacking, though. I worked inefficiently and was a lot of times at a loss when it came to doing things like testing and debugging. So really, I was lost a lot. Because let's be honest, we spend a lot of our time as developers squashing bugs. And unfortunately, I don't think that my experience was all that unique. Because the majority of coding bootcamps leave graduates with knowledge gaps in essential skills like debugging, and a lot of us struggle at our first jobs because of it. Now, when I first started learning to code, seeing an error pop up was really scary. It was my code telling me that I did something wrong and that I had made a mistake. And since we've all been conditioned to avoid mistakes in life, it felt like a failure. The big red error messages reminded me a lot of the big red X's that my teachers used to put on my tests in school. They were intimidating me into inaction, and as an attempt to avoid these error messages, I just didn't run my code as often because, well, you can't get error messages if you don't run your program. I would write code in the bubble of my text editor and then stare at the screen wondering if it looked right. Now, the only indication that I had of rightness was my very limited knowledge about the programming languages that I was working in, and maybe an example or two. So as you can imagine, I wasted hours upon hours trying to make things right before I would execute any of it. And when I eventually let the program run, it of course didn't work. Without having been taught how to debug or seeing anyone demonstrate it, I didn't know how to approach it. I didn't know that how to read an error message. I didn't know that I should be reading those error messages. So my only approach was staring at the code, comb through it line by line, and just hoping to find any typo or obvious mistakes. No one told me that there were better ways, and I practiced myself into bad debugging habits without knowing it. Now, don't get me wrong. I'm not saying that bootcamps don't produce quality developers. In fact, I think more companies should be hiring career changers and bootcamp graduates because we bring past experiences and soft skills that are sometimes harder to teach. But that's a 40-minute talk for a different day. Now, there's only so much that you can cram into someone's brain in the course of 3 months. So I do understand that coding bootcamps have to make compromises in their curriculums. They usually end up focusing on things like syntax or super basic practices like assigning variables and making loops and defining methods. Things like testing and debugging just get shoved to the side. After I finished bootcamp and started working, it was really apparent and very quickly that there were better ways to fix bugs. I had to change what I was doing, that whole staring and hoping thing, but I didn't know what to replace it with. The part of my brain where knowledge about debugging should live was a big empty gap. And I had to overcome it by filling it with the proper tools and strategies. At Tandem, we pair program all the time. And I think pairing gave me an opportunity to observe a more experienced developer at work. I have a really supportive team that lets me openly confront what I don't know and encourages me to ask questions. We would break things together and fix them as a pair. It gave me exposure to how different people like to approach bugs and errors and the different options that were available to me. For instance, my coworker Shamail, he's really great about using the network tab in the DevTools, and Sasha is just a wizard in the Rails console. Now, someone really smart said to me once that in software, you have to break everything first before you can piece it back together and make it work. Now, this applies to learning too, I think, because if we can't admit what we don't know, we're not going to let ourselves learn it. And having a supportive work environment allows me to identify my knowledge gaps so that I will know when I see something that I want to store in those spaces. And that can be a new approach to a problem or maybe a new tool. And what I want to achieve in the next 30 minutes with everyone is to share with you the more important lessons that I had learned about debugging over my first year or so working in software. I'm not trying to turn any of you into master debuggers. We, first of all, don't have time for that. And it's really not the point of this talk. But if you do walk away with even one thing that you didn't know when you walked in the door, I would have done my job well. So I've organized the things that I've learned about debugging into 3 main categories of lessons. Lesson number 1, look under the hood. Lesson number 2, tap the phone lines. And lesson number 3, find a bug, write a test. Now, these are not meant to be roadmaps, but rather starting points where we can begin the process of debugging. And depending on the issue at hand, we can use one of the 3, mix and match them, or maybe go another route altogether. And all the examples in my presentation are done in Rails, but other languages, obviously, and frameworks generally have equivalent tools, and the core ideas are transferable. So, on to lesson number 1. Look under the hood. All right, so maybe I was exaggerating a little bit when I said that my bootcamp didn't teach me anything about debugging. We were told to console log everything. So I was aware that I can tell the program to print out certain things. We mostly use this to get a look at values of variables at runtime, compare these printouts to expectations, and figure out where our code needed to change. So I did know about the concept of print debugging. In Ruby, we use print, put, or p instead of console log. Now, all 3 of these do very similar things. They output information from our program into the console. But where print and puts internally calls toS to turn the thing that we want to output into a human-readable string, p calls inspect internally, giving us more useful information as developers. For instance, if you take an active record object, a puppy named Dottie, so inside the Rails console here, we'll be able to see the difference between using puts to output our puppy object and using P. So depending on what is useful for your circumstance, it's important to know the difference between them and remember that they are both available. And in this case, we would opt to use puts if we needed to know which class our puppy belonged to, but P is going to give us more specific information about this particular instance of puppy. Now, print debugging lets us leave breadcrumbs in the form of these print statements around our code and visually track the path of our program and look at actual pieces of data. We can watch and make sure that all the data is as expected, and if an output that we expected to see didn't show up at all, it is safe to say that our program just never hit that section of code at all. Now, Aaron Patterson, Tenderlove, is a famously self-proclaimed puts debugger. A link to his blog post is included at the end of the deck, which I will share later. Most of the things that he covers in the post does feel very much over my head, but he also makes a very powerful case for print debugging. And honestly, what we just talked about is really the extent to which that I use these print methods. I usually use something like pry, which is a gem, for peeking under the hood of my Rails application. So like I said, pry is a gem that it will allow us to open up a console session at any given point of our program just by dropping in the line binding pry into the part of our code that we want a closer look at. We call these breakpoints. So the next time that we run the program, it will pause there and give us an interactive console in the terminal. That's why something like this is called interactive debugging. It serves largely the same purpose as using the print methods to explore the inner working of our program, but pry will give us more freedom in our exploration. Now, I have a simple app here that I built back in the day to try to teach myself Rails. It's called Puppygotchi, and it tracks the puppies that each user owns. These puppies, they will get hungry or bored over time, so the users can log in to check on their kennel, feed, or play with these puppies. It's inspired by Tamagotchi, if you remember those. So I have put a couple of breakpoints here in the service object that I use to age the puppies and set their hunger and boredom levels. We also have a few private methods that are folded below the keyword private there at the bottom. So if we reload the page in the browser, we see that the load will catch and appear to be unresponsive. So if we pop into our server logs, we can see that the request from the reload hit the server and then stop at our first breakpoint. Now, most things that we can do in a Rails console or an IRB session are available to us when we're in a pry session. But the gem also gives us a lot of extra commands to get more information about the program. Now, one of these basic ones is ls. Using this command, we can get an overview of everything that is available to us within the current context, which is this puppy aging service. We can see from the output of our ls command that the service object has a public instance method process, among other things, but it doesn't show me the private methods because I don't have access to them from this context here in pry. Now, a gem that's used sometimes side by side with pry is called pry bybug. This gives us commands to navigate through the code base, and the ones that I most commonly use are next, step, and continue. So since we're still pried into the initialized method here in the puppy aging service, you can see that we are stopped in line 4, and we can tell this because the arrow on the left of the line number is where we are stopped. So that line of code is telling our puppy instance variable to point to the puppy object that we passed in when we initialized the service. Right now, that line hasn't been executed yet. So if we look at our instance variable, it has no value right now. Its value is nil. But if we use the next command, the program will run the next line, set the result to the variable, and stop at line 5. And we can then see that puppy has a value now. So at this point, if we have looked at a couple of variables and ran a few commands, our terminal can get a bit messy. What I usually do is clear it up, clear the display, and use the command where am I to get reoriented in the price session. Then from here, if we want to have a look into the change time method, whose result is being set to the other instance variable time elapsed, we can use another command, step, to step into this next method call. This lands us into the definition of change time, which is a private method that's defined on our puppy aging service. Now, sometimes step will take us into real source code or the source code of some external library that we are using. It's important and sometimes hard to remember not to panic when our price session ends up in the middle of unfamiliar code. In fact, really, that's kind of the point, is to dig deeper into the program, whether that's code you wrote yourself or not. Now, the last navigation command that I wanted to demonstrate is continue. What continue will do is tell Pry to continue running the program until it hits the next breakpoint, which, if you don't remember, we do have in our public instance method process. And when we're done with the session and want our program to carry out the rest of the actions, we can use exit to get out of the Pry session. And then the program will continue running as is. Now, being able to peek under the hood of my program was such a game changer. The hardest part of learning to code, for me at least, was overcoming the disconnect between the text that I'm typing into the files and what shows up in the browser. It's especially hard to conceptualize when working with a dynamically typed language like Ruby, where we can assign data of any type to the same variable without any warning about potential problems. Although that might change soon. Has anyone seen an error message kind of like this before? Yes, maybe? Okay. The actual method name in this message changes, but this error and I are very close friends. I see it all the time. If you're unfamiliar, what this message is telling us is that the program wants to invoke a method called select on something whose value is no. Now, in this particular example, select is a built-in method on the array and enumerable classes. So if the object it's being called on is anything but an instance of either of those classes, this method call will result in this error. And it is a message that we will see every time we try to call a method on something that has the incorrect data type. Now, since there are many answers as to where, how, and why the data is unexpectedly no, opening up the program using put or pry is a fairly decent place to start this debugging process. We can use these tools to identify the problem spots and follow the clues from there to a solution. So our lesson number 2, we're going to tap the phone lines. So I work at a consulting agency where all of us are polyglots. The project that I'm currently working on has a Rails API backend and a React front end. So testing features in the browser as we write code is a fairly standard practice in our typical development flow. Usually when things aren't working properly, the best case scenario is that we would see some kind of error in the JavaScript console. But many times that just wouldn't be the case. All we would see is an unresponsive UI or a blank screen. Now, something that's really useful in these cases is built right into the browser. If we open up the DevTools, we can see all of these tabs. First, you have elements, which will be your HTML and styling, your JavaScript console, and for me in the Chrome DevTools, that fourth one over is a tab labeled network. This tab will show us a log of our network activities. It's something that we would use to make sure that the resources are being downloaded or uploaded correctly, and where we would go to check the status of our application's trips to and from the server. When we first open up the DevTools, you won't see any network activities logged there yet. So let's go back to PuppyGotchi again. With the DevTools open there, we can see that the network tab is empty. Once it's opened up, we can either reload the page or repeat the action and watch the logs populate with all the network activities. So each row in the table at the bottom represents an HTTP request, and the columns give you more information about each of those requests. The ones that I look at most often are the name of the resources, the status, which is the HTTP response code, and the resource type. Some lines will appear in red if there are bad requests, like something like a 500 or a 403, which are internal server error and forbidden, respectively. Now, when we click into one of these lines, we will have access to more detail, like the request and response headers and the response body. These sections will let us look at the communication more closely. What I typically do here is check to make sure that the requests are going out to the server with all the information that the backend needs to properly process them. And under headers, there's a request payload section that will tell us what information went out to the server. And we can see whether it's behaving as expected or identify where it's not. Now, on the flip side, there is a response tab that's going to show us what came back from the server as a result of our request. In this case, it looks like our request resulted in an internal server error because it raised an argument error on the backend. And what this means is that our UI sent a request that tried to invoke a method by passing in the wrong number of arguments. Now, this demonstrates something that's often easy to overlook, that even though a bug manifests itself on the front end, doesn't always necessarily mean that it's something wrong with the front end code. I have been tricked by this and spent a lot of time investigating the React code only to realize that it's actually a back-end issue, disguising itself as a front end error. We can also look for similar information from the server side by peeking into the logs. Now, this is where the server will log information about each request coming in, how the server resolved the requests, and the result of those requests. This is also where exceptions and warnings will show up and where our price sessions will open if the program does hit a breakpoint. This is what the server logs look like for that refresh that we just did on Puppygachi, where we saw the network logs in the browser. Like with the network tab, we can see the HTTP request and which route it hits, the response status code, and the exception that was raised, which we saw earlier is part of the response body. Now, monitoring lines of communication using the network tab and server logs require us to be familiar with our program. And as we can see, the logs don't always tell us when something is misbehaving. They're definitely not always color-coded. So knowing what these requests and responses look like when everything is running properly will help us recognize where it doesn't. And finally, lesson number 3. Find a bug, write a test. Now, bugs and errors are a normal part of software development because developers are only human, but we also want to make sure that any future code changes that we make won't create regressions and result in the same bugs over and over again. A lot of times, bugs exist because we fail to account for and write code to cover certain edge cases. Most of the time, the program will run without issue, but ideally, our program will run seamlessly for as many end users as possible. Tests to cover the conditions under which our bugs show up will prevent the code regression that we just talked about and let us know when the bug has been fixed. Running the tests also gives us clues about how to proceed when looking for a solution. For example, so recently, my pair Shemail and I were working on something where we had to write a method to sort some active record objects into a list to pass to the front end to display. We had one database query that returned an active record relation, which is a list of evaluations that you can treat like an array, and another query that returned one single evaluation. The purpose of our method was to squish the result of these two queries together into one list, sort it based on certain attributes, so that the front end will display them in the proper order. Now, in our implementation of this method, we wrote tests to cover all the cases that we could think of. With a fully green test suite and the UI revealing no unexpected behaviors, we created a pull request for the feature, and after the team had reviewed it, we eventually merged it into the code base. A couple of hours later, when Sasha was working in the QA environment, she found that the page we worked on was broken. Now, after a little bit of investigating, she concluded that the page couldn't render because one of those two queries to the database returned nothing. So our method was adding a nil to the list of objects that we passed to our front end to display. But when React tried to display something that was undefined, everything fell apart. So I ended up working with her to find a solution for the bug. And the first thing that she suggested we do was write tests to account for this particular state of the program. Our test basically said, if one of the queries comes back with no result, we expect it to be excluded from the list that we passed to React. Now, at the time, we didn't know when we started debugging what specific lines of code we wanted to change or needed to change, or what that change looked like. But backed up by the tests, we would know right away when it's been fixed. Not only that, each time we tried a solution, we would run the tests, hoping that they would fail in new and exciting ways that would inform our next steps. Now, sometimes in our jobs as developers, it feels like we're just killing bug after bug. We fix code almost as often as writing new lines of them, and good debugging habits are almost as important as writing clean code. Some will argue more important. And for the developer that I was a year ago, that was a really anxiety-inducing idea. I could have written you method after method that did something, but I had no idea how to find that variable that was unexpectedly no. Like, where did it go? Fortunately, I work with really smart developers. They have a lot more experience than I do. And through pair programming, I was able to piece together a little something from each of them into my very own debugging toolkit. So that little by little, I was gathering lessons to fill up those knowledge gaps that I have found in myself. Now, if you think about it, in a perfect world, boot camps will put more emphasis on teaching debugging techniques and letting their students practice them. It will prevent their graduates from learning bad habits and prepare us better for our first jobs. But as is, I think we can help each other by sharing what knowledge we do have and admitting openly about where we do not. Because I knew early on that, hey, I don't know what to do when something breaks. I was able to focus on that and learn the lessons that I'm sharing with you today. Now, to close, I like to go back to Tenderlove again. I found a tweet the other day that he had pinned from back in January. He said, "It's not a bug, it's just taking the code path less traveled." Now, knowing him, he was probably making some kind of a joke. But this actually made me feel more at ease about debugging. Because when we frame it in this way, errors and bugs are just edge cases that we haven't considered yet. So we really shouldn't be intimidated or, felt like we were a failure somehow because of them. And I hope that after the time that we spend together, you do feel more equipped to confront your next bug or error. Thank you.